Thank you for joining us today. My name is Christine Van Leeuwen, and I am a member of the Illuminating Engineering Society. I'm the Marketing and Communications Chair for the IES Raleigh section. I would like to welcome you to our presentation, Lighting 101, Basics of Circadian Lighting. This talk is part of a webinar series we're offering in the Lighting 101 category. Today, we're happy to welcome Pacific Northwest National Laboratory. Let me introduce you to Dr. Lynn Davis, a fellow at RTI International, who will introduce you to our speaker, Andrea.
Thank you so much, Christine. It is my great pleasure to introduce to you a good friend of mine, Andrea Wilkerson at PNNL. Some of you may have met Andrea at various lighting conferences over the last few years. But in case you didn't know, Andrea is a senior lighting research engineer at PNNL, focusing on the evaluation of emerging lighting technologies in realistic settings. And she'll share some of that knowledge with us today. She has a doctorate from Penn State and a BS and Masters of Architectural Engineering from the University of Nebraska. So Big Ten schools. She probably likes her football. Andrea serves as an Associate Editor of LEUKOS, the IES technical journal, and is president of the International Association of Lighting Designers Education Trust Board of Directors. And she serves on the National Council of Qualifications for Lighting Professionals Exam Committee, and also the Oregon State University Civil and Construction Engineering Industrial Advisory Board. So as you can see, Andrea has been involved in a lot of different aspects of lighting. And so it's my great pleasure to welcome her today to share with us more on circadian lighting. Take it away, Andrea.
Thanks, Lynn. Happy to be here and glad you reached out to provide this opportunity. Learning objectives, my goal today is to help clarify some of the things that are sort of being said in the industry or terms that are being used, and then also just provide a broader perspective on this topic. But we are focused on building technologies, emerging technology, and for me, it's a focus on lighting. And I've been at PNNL for about 10 years now, so I've got to see quite the transition from technology of the A lamp costing $50 to now it's $2 or less. And so the lighting program continues to remain focused on energy savings. That's why the Department of Energy invested so much money into advancing solid state lighting. It's because there's such great energy saving potential. But really, at this stage, LED adoption is happening, but there's a big focus on making sure it's done well, that systems are working, especially when it comes to advanced lighting controls. And, there's just a lot of different challenges in the market when it comes to deploying those, as well as, again, a lot of the emphasis today will be on this aspect of, yes, we want to save energy, but we also want people to be happy, healthy, motivated in their environments, and to have lighting to be able to perform the tasks in their workplaces, etc. So that continues to be a big focus as well. And my area that I've worked on actually the entire time that I've been at PNNL over the past 10 years has always been in getting out in the field. Now, obviously with COVID, there's a couple of years where we didn't really get to get out in the field, but coming back, it's just, again, it's so exciting. My passion is just really understanding how people respond to lighting. And so, yes, we can have this new technology, but is it meeting people's needs? And how could it provide better value to people in these spaces, as well, again, as always, keeping energy savings in mind. And so today's talk is really going to focus on this idea of, circadian lighting and sort of related terms. And I think I would say there's different people, different perspectives on what terms are best. Some people don't even like the term circadian lighting. But we're just going to step through and sort of see where these different terms come from. So taking a step back and sort of when did this area of light and health really get kicked off? I would say the seminal research really happened in like the mid 70s, and so there was a researcher at the National Institute of Mental Health, Al Louie, and he happened to hear a talk about melatonin. A Nobel laureate had come through to give a talk at NIMH and happened to bring this up. And then also Al Louie ended up having a family trip to Australia to visit some relatives. And so with this interest in melatonin, and then this trip to Australia gave him the perfect opportunity when he returned back to the US to test his own melatonin levels. And basically, he expected that his melatonin would be high when he returned to the US because it was still to his body night. And that actually wasn't the case. His melatonin levels were low. And so this is really what led to this seminal work that was published in Science, documenting the suppression of melatonin by light. So I always think it's good to like keep in mind that it's not like this research just started in 2001 with the discovery of the intrinsically photosensitive retinal ganglion cell. This has been research that has been happening for a long time, and it's just 2001 provided a lot of clarity, and I would say encouraged further research in this area with the discovery of the additional photoreceptor, but it had already been happening. And for those of you unfamiliar with sort of the research world, getting work published in Science is sort of like making it to the Olympics as a researcher. So the fact that this got published in Science long ago, they saw the importance of this research and the value really that we're still understanding further today. So, okay, what is circadian lighting? So really the idea of circadian lighting, comes from about a day. And this idea that our melatonin varies throughout the 24-hour day and actually varies about just slightly over 24 hours. And then also we have cortisol and other things in our body, our core body temperature, that are also varying throughout the day. And light really serves as a way to help us keep aligned with the 24-hour day. Again, given that on average, people's melatonin concentration tends to vary a little bit longer. And so something I also want to point out, though, is melatonin also increases at night in rodents. So it's not that melatonin is what causes you to sleep. It's just a signal. I would say that's where a lot of researchers land. It's more of a signal to your body, just like rats. It's a signal to their bodies, but that's actually when they're awake, unlike humans. So I think that's a slight little bit of knowledge that helps you keep in mind sort of the role of melatonin. Okay, so we have, so then there's this other term that sort of gets thrown out, melanopic lighting. So we have melatonin, which is our bodily hormone that we just talked about that plays a role in sleep. Some people will, another way to think about it, they call it the Dracula hormone, comes out at night. So you want it increasing at night. And then there's a photopigment in our eye, melanopsin. And so that changes when exposed to light. So those are two different things, but I think especially when we use terms like melanopic lighting, it can get a little confusing what this all means and those differences. Okay, so another thing I really want to highlight is to keep in mind when you're thinking about this broader topic of circadian lighting is that there are multiple metrics and there are different results. So what I have listed here are really metrics based on melanopic, the melanopic sensitivity curve, which I'll detail here in a little bit. So again, going back to this eye photopigment, melanopsin, and so that's what these metrics are based on. And then there are circadian stimulus, which probably many of you are familiar with. But again, that's really focused on characterizing melatonin suppression in response to light. And that's what that model is characterizing. And then there's some metrics out there that more are just looking at, okay, what's the amount of short wavelength blue light? And they're sort of using that as a way of quantifying. So as in LUCE is a little not meter, but I'd say a wearable device that you can use to sort of approximate your exposure to light. And so they came up with this like stimulus metric, really just to broadly quantify how much short wavelength light are you exposed to. So an example of that metric and application. And then recently there's a paper published that I think had a figure at the end that sort of really highlights how these metrics can vary. And so this is showing two spectral power distributions that are very similar. So you can see the CCT is very similar, the different color rendering metrics very similar, but you get very different CS values. And also, but then you can see that EML is very similar. So these are just some of the nuances of the metrics. And so I remember the first time I did the CS calculation and then was doing an EML calculation and saw that difference. I got a little concerned that maybe I wasn't calculating it right. And so just putting it out there that you can get different responses from the different metrics. And then again, I think an important part, especially, you know, in my work, it's really trying to figure out, okay, so we are learning all these things in the laboratory, but then how are these getting translated into the field? And we, you know, we come alongside and we're not prescribing like, oh, this is what you should do if you want to have circadian lighting or circadian supportive lighting throughout the day. We just come alongside and document what other people are doing. And so we get to see sort of like how what's being talked about in the industry sort of gets translated by different people into application. And so I just wanted to point out that, again, these metrics are really coming from laboratory research. And when you're doing laboratory research, and you're really focused on controlling all the other influences because you want to find something that you want a statistically significant finding. So you are trying to make sure that, again, things like sound could influence you when you're responding, or what was your prior exposure to light. And so you can see with these two studies in particular, and we'll actually touch them on a little bit, the participants are coming in the middle of the night and doing these experiments on melatonin suppression. And so while yes, like that's showing us how light suppresses melatonin, it also doesn't necessarily translate to the daytime because your melatonin should already be suppressed for most people during the day. Just wanted to point that out as well. And sort of that's why it gets like a little tricky translating what's happening in the middle of the night with melatonin suppression to the day when there's really not much melatonin to suppress for most people who are day active and have a normal sleep-wake cycle. Okay, and then one of my personal favorites, human-centered lighting. So I think this one might be the term that is the most ambiguous and not sure. It means different things to different people. And for me, again, it goes back to, okay, it's lighting for humans. And I think it gets used a lot for maybe meaning more circadian lighting, but to me, we should, and I think I've done a good job in the lighting industry and within the IES and IALD of, hey, we're designing for the people in this space. And so there's really multiple factors that are going to have varying levels of influence when it comes to lighting on both your vision and your circadian regulation. So this is a paper that was recently published in LEUKOS, which is actually free. As a reminder, it's free for IES members to access LEUKOS and the journal papers in LEUKOS. So this list of mediating factors wasn't random, it was intentional. And it's really showing, it's listing the most influential to the least influential, again, on all these different processes. And so timing, as we just talked about, right? If you shine a bright light in the middle of the night, it's important to understand that will have a different effect on melatonin than if you're shining a bright light during the day. Something I think kind of gets left out when it comes to importance is intensity. So the intensity of light is important. Again, that directly relates to the amount of short wavelength light, as well as, again, what wavelengths. And then another piece, I think that's a little trickier in some ways, and you kind of see that. We talk later about how sort of this laboratory research is getting translated to recommendations, is the timing and duration piece, and then also light history, which also gets very tricky when you aren't carefully controlling things in the laboratory and you're thinking about, okay, how does this translate to the field? And then also, there are many influences on circadian rhythms and health and well-being. And so I have a couple of, a quote from Peter Boyce in one of his recent papers where, you know, he notes that well-being is like so all-encompassing. That's more, it would be a miracle if lighting didn't affect well-being. So basically saying we shouldn't be surprised. And then also that the Onion, even like back in 2017, so I would say in the earlier days, I mean, they just got it, right? It's like, it's more than light that influences. So yes, you can cut down on blue light before bedtime, but it's also like, what are you doing throughout the day? Or, you know, another researcher has commented on, okay, yes, like maybe you have night shift on your phone before you go to bed, so you're not getting as much short wavelength light, but what are you doing? What are you reading? What kind of content are you consuming before you go to bed that actually might influence your sleep more so than a little bit extra of short wavelength light? So just some things to keep in mind. And then part of our research, we had looked at, this is more on that, like the Department of Education. They use this model of what they call like the theory of change. So when we were actually writing a proposal to the Department of Education, they forced us to think about, okay, what is our theory of change when it comes to lighting and how we think that can influence people? And this theory of change was actually developed for the office environment, but it's sort of like, okay, we have all these little lighting attributes that we can vary, but then there's all these other things, right? So your workplace motivation and happiness is not going to be just lighting. It's going to be your boss and maybe how well you slept the night before and all those things. So again, I think it's like keeping the broader picture in mind. Like, yes, we want to do what we can with lighting, but there's a lot of other influences that we can't control. And this in particular is what makes lighting field research so difficult, is that there are all these other factors that influence that when you're doing research in a laboratory, you can really control, but you really can't control these when you're trying to see, you know, find significant effects in the field. And then another piece I think that's important to keep in mind when you're thinking about light and health and recommendations is also that people respond differently to light exposure. And so this is a figure from the IES where they're showing even, you know, you're getting less short wavelength light into your eye as you age, as well as the longer wavelengths. And I think this is particularly important to keep in mind when we're dealing with senior care facilities where, you know, we have to balance sort of these visual needs and we need to make sure people don't trip, etc. And then some of these need like circadian supportive lighting. So, you know, brighter light during the day, especially think in 24-hour environments, it's wise to consider these things carefully. And then you're dimming lights at night, but you don't want to dim them too much because you still need people to be able to see. And I think also gets tricky about this is things like cataract surgery. So how many people have had their a cataract surgery, and so then you know, how do you sort of blend the lighting for that piece? And I don't have the answers. I'm just bringing up all the considerations for those of you who work in these environments. And then also there's some interesting research by Andrew Phillips a few years ago, And he looked at even the variability between different people and sort of how they are responding to light and sort of how their melatonin suppression varies in response to varying intensities of light. And so again, I think that's something else to keep in mind. To get to recommendations, we have to simplify, but that can also sometimes lead people to think like, oh, this is the case for everyone, when it's not. And then, I work for the Department of Energy, so I have to comment on the fact that a lot of these recommendations can be pretty hard to meet with current power density allowances for lighting. And also, if we're trying to meet these, it's going to increase light levels quite a bit on the horizontal task plane. And so the question becomes, is this comfortable? Is that too much glare? Do people find these environments acceptable? So some simulation work we did showed that you're basically tripling light levels on the horizontal task plane in order to start to meet some of these CS and EML recommendations that are out there. And that research is now published on the DOE website. So there's a link there if you want to go look at that more carefully. And laboratory research on and sort of where the metrics come from. So actually the two studies I have listed are sort of the foundation for the CS metric. And as I brought up earlier, that's again, you're translating sort of some data that was taken at night in terms of how people respond to light when their melatonin is high. And in general, it's getting translated during the day when melatonin levels are relatively low. So I think that's what makes that particularly challenging to figure out, like, what does that mean during the day? And like many things, just pointing out that like we're all learning. And so there's been some even more recent changes to circadian stimulus. It was that metric was first released in 2005 in that model. And there's been some more recent updates. So what I suggest, if you're trying to keep track of it all, is simply just to go to the website. I think that's the easiest way. And if the math gets even, I feel like, a little more complicated over time as there's new variations in the CS metric. And so you can just go to the Lighting Health and Research Center, their website, and you can actually put in your own SPD or pick a different SPD, and it'll calculate CS for you. And actually, I think I hadn't noticed this before, so relatively recent, they also added some of the CIE alpha opic quantities. And so we'll touch on those here in a second if you're not familiar with those. So another tool you can look at is the IES now has a spectral calculator. So this actually touches on a couple things. So you can calculate your TM30 color rendition data when you enter an SPD. And again, they have a huge library, hundreds of light sources you can choose from. But then also you can input your own, and they've really added a lot of functionality to this. So you can use that library, import your own, calculate TM30, and you can also calculate that CIE alpha opic quantities. And so there was a transition between EML and sort of these alpha opic or melanopic EDI you may have heard of. And basically EML doesn't align with the standards for how you units for metrics. And so that's where these alpha opic sort of quantities came from. But I would say underlying, it's like very similar. And I think that's what almost gets a little confusing, is like there's so many variations of the same basic principle of we're just really focused on that melanopic sensitivity curve. And so there's resources here if you want to go dive more into these. Okay, so looking at the melanopic response, again, as I mentioned earlier, this is really the core of a lot of the metrics that are currently being talked about in the industry. And so when we're talking about EML, or M/P ratio. I'm just going to step through sort of what that means. So as we have our photopic weighting function or photopic sensitivity curve, and which is peaks at around 555 nanometers. And then we have our light source. We're multiplying those wavelength by wavelength. And then also we're going to do that for a melanopic curve. So again, sensitive around 480 nanometers, and multiply that by our same source. And then you sort of can understand the melanopic content of that source, or you can understand it. And then you can use that ratio. And actually, I'm going to skip ahead one slide. So you would use that ratio, multiply it what you measured for your photopic illuminance, and then you would get EML. And I just want to point out, though, that there are a few different ways sort of these M/P ratios can be calculated. And so my colleagues, Naomi Miller and Leah Irvin, they actually documented the 4 different ways if you really want to get into the nuance of all of this. And they also provide a cheat sheet or a cheat table if you don't want to get into all the nuance, but feel like you need to between the different ways of calculating the M/P ratio. And then, so I just, again, want to touch on, we're all learning, there's a lot of things. And if you think about it, like, 2001, discovering a new photoreceptor in our eye, it's not surprising that's going to take a little while to sort of figure out, okay, what can we learn in laboratory? How does this influence us? They're learning things, even, how we have a separate pathway that influences our happiness. And then how do we translate that into real buildings? And as we've sort of touched on, there's a lot of nuance, but you have to start somewhere. So I would say WELL has taken a pass at this over time. I'm just highlighting some of the changes. So you can see in 2016, really they're shooting for over 250 EML at 75% of view positions. So we talked earlier, they just said 4 hours at that time. And then they became more refined over time. So then, sort of another iteration was, okay, we need it from 9 a.m. to 1 p.m. Another iteration was, or I guess the more recent iteration is like, okay, we just need 4 hours and start by noon. And so I just wanted to show this to show, like, we're still learning, and I would say expect more slight changes in the future as we learn more. Okay, so then getting to maybe what you're really wanting to know, like, what SPD do I need? Do I need it to vary? Do I need the spectral power distribution to vary throughout the day? And I would say, as we sort of touched on it, it depends on who you ask. There's sort of different researchers who prefer different metrics, particularly I would say in the US. And so depends on who you ask, but also if you think back to, or think about how much research has happened in exercise science and how long that's been going on, then the fact that, like, we sort of have settled on, or Fitbit anyway, has settled on try to get 10,000 steps a day, or some other researchers came out and they're like, we need to move more and sit less. So those are like very basic guidelines. And so I feel like that's sort of where the lighting industry is right now, and might stay for a while. So I would say the one thing that physiologists, chronobiologists agree on is, okay, we need bright days and dark nights for people who are day active, normal sleep schedule, and or something like less light is sleeping, or less light when sleeping. That there's sort of these high level guidance we can give right now, but again, it's when you start to think about, okay, well, what's your application? Is it a 24-hour care environment? Is it a place where you need to balance the needs of the nursing staff and then the people who are trying to heal, or an airport or an office? So each of those spaces is really going to have different needs, and then even within those, we've seen people sort of take different approaches to even sort of the extents they go to when they're doing tunable lighting throughout the day, or maybe they're not doing tunable lighting, but they're really just trying to increase light levels throughout the day. And another piece that we're particularly focused on at PNNL is really making sure that we're accurately modeling these things, because a lot of times, over design can happen. And then especially when you're concerned about, I'm going to do, I'm going to put in all this effort to try and obtain these 3 well points. You definitely don't want to barely just miss them. And they're actually, like, if you dug into like the actual guidance, that will give, there's a lot more wiggle room than maybe those recommendations apply or imply when you first read them. So if you are thinking about going for a well, I would say read the wiggle room, because that will make you feel a little better. But again, we want to make sure that we can accurately model the spectral characteristics. So when you're thinking about the visual field, the vertical visual field, there's all these different light sources, lights being reflected off surfaces that really need to get taken into account. And so we're working through some additional DOE funding to really try and help refine some software that can more accurately take into account the different spectral power distributions of different sources in a space and the different spectral reflectances, so that we can get to a place where we're improving the accuracy of our modeling. And something else that we focused on with this modeling effort is also just understanding how much light varies in the vertical plane. And fortunately, I didn't have time today, but we're doing some really interesting work in an office and factory space, and then an R&D area at ETC, if you're familiar with them, and looking at how does lighting vary in these different spaces throughout the seasons. And so I think it's just within lighting, it's hard to like transition. I know for myself anyway, it's hard to transition from, we've just been so focused on uniformity in the horizontal plane. And that's a lot of times how we, I think, can think about lighting in the vertical plane, but lighting in the vertical plane is just so variable. And then when you're taking into account, especially in places where people are moving a lot, such as healthcare nursing staff, there's a wide variation in what they're exposed to throughout the day. And so again, I think trying to capture some of those nuances to feed back into recommendations. And so this is actually what we're, the sensor we're using from Blue Iris Lab. So it's actually building on some earlier work by the Lighting Research Center, and they developed this dynamimeter. And so sort of Eric Page at Blue Iris Labs has taken the next step. And so using different sensors across the visible spectrum and really trying to more accurately characterize what's happening in a space. And as we're trying to collect all this data, it's very helpful to have distributed sensors where the data can get uploaded. And so we had about 10 to 20 of these installed at ETC, moved them around to different spaces over a span of 6 months. And so that's what we're working on analyzing right now. But again, going back to this idea of like, we really want to understand like all the pieces. So, we understand what's happening in the lab, but then that translation piece of getting it from the lab to the field, where there's just so many different influences. And so understanding, well, what are people exposed to now? And then sort of, does there need to be a supplement to that? And then this is an office research project that we've been working on, or that we actually wrapped up at IMEX and their downtown Chicago offices. And so we were trying to understand, again, getting at this question of like, okay, let's take a real space and let's ask lots of questions. We tried, we used Fitbits to track their exercise and asked lots of questions about lighting satisfaction. And this took place in October, and then we sort of did it again, repeated the same process in January. So once when the lighting was static in that space, and then once when it was tunable. And so I don't have time to get into all the results from the study. I'll touch on a few of them, But I think just going back to this idea of like understanding like the horizontal work plane versus the vertical work plane, we did take some measurements at each workstation, horizontal and vertical. So that's what I'm showing here. Some people were standing, some people were seated. And a lot of times they're sort of like, oh, there's this relationship between horizontal and vertical illuminance. But I think it's a little trickier maybe than that. And that's what some of this data shows. It's like that relationship isn't maybe as clear as some of the past guidance has suggested in that piece. And then I also think, one of the interesting results out of this just comes from the surveys themselves. And this was like right as sort of people were maybe transitioning back to the office, and then there's a little step back in that. So it was in the winter of 2021 into 2022 when we did this, and you can see that people aren't spending a ton of time in the office at that point. But I do think the one thing that was super interesting from this data is also how many people look at an electronic device within 1 hour of falling asleep. And so just thinking about like, we can do all these things in offices during the day, but then there's a lot that's like uncontrollable once people leave. And so really thinking about all the influences that can happen. And then if you're not familiar, I always like to touch on, there's Cochrane does these systematic reviews, and I think they're helpful in that they take a very, they don't assume you're an expert in an area of research. Unlike when you go to read most journal papers, they actually assume they have like, normal people language explanation of their results, which is really nice. And so there's a review that was published in 2018. So it is a little dated, and hopefully they update that soon, but it's really just saying like, there's still not like a high quality of evidence to show many of these, I would say, claims maybe that get thrown out about like the how certain lighting can improve alertness, or how certain lighting can maybe support your melatonin. So I think that's something to just keep an eye on. And then another piece that I haven't talked about, I touched on a little bit earlier, is this idea of, if we're going to have these higher light levels, there's things we need to take into account, such as glare. But in that earlier study, when we were getting, okay, you're going to need to increase light levels 3 times to sort of meet these different metrics, we didn't take into account daylight. And so my colleague, Sarah Safronic, and others at PNNL sort of took another pass of like, okay, what if we do start to look at the role of daylight? And I would say one important piece to that is that when you're incorporating daylight, there's pluses and minuses, right? So you're increasing the light level not from electric light, and so you don't need as much electric light, but then also you have to take into account glare. And so they just looked, throughout the year in a simple office, when would someone sitting at their desk, perhaps experience intolerable glare. And this is something they presented at one of the IES conferences. And so feel free to reach out to me if you actually want to dive more into the details of this. But I just think, again, sometimes it can be like, okay, well, we'll just add daylighting, but it's really understanding sort of the pluses and minuses that come with that daylighting piece to get to these higher light levels. And then again, there's the energy story. And so sort of that balance of like, you could increase the color temperature of the light to 6200 to increase the amount of short wavelength content. But we see again and again that most people don't find that acceptable. And I would say even on sort of like the opposite end of that, so with the IMEG study we did in the offices, they actually had, I think the lighting dimmed down to, or tuned down to 3000 Kelvin, around like 530. And people just really didn't find that acceptable. And I'm not sure if it was like a reminder, like, oh, I'm still at work and I don't want to be at work. etc. But I think so, on both ends, there's some work to do of like, what do people find acceptable? Sort of how do we balance these visual needs and non-visual needs to create the best environment for people. And then, okay, so this is my brief rundown of some of the takeaways to keep in mind. Again, we're still learning. I think in some ways, while it might feel like we've known this since 2001, it's like, well, we kind of have known this since the mid 70s, and it just takes time to build up the evidence needed, especially to, I would say, reach additional clarity on recommendations, especially for particular applications. And, your melatonin is already varying throughout the day. It would vary if you were in an all dark room. It's just that light really helps us keep in sync with the 24-hour day-night cycle. And there's multiple metrics. I think that can be a frustration for some because they would like it to be a little simpler and can't we just all agree? But also it's just part of the scientific process and we're still learning. And so there's multiple approaches and I think we can learn from all the varied approaches that are being taken. And again, light is not going to solve all of our problems, as most of us know, but we can also keep working towards understanding, how can we create the best environments for people and do that in a way that's responsible with energy use. So I did want to touch on the IES does have TM18, which I found like very approachable when reading, and I think about this a little bit more maybe than most, but still, I think it's a great resource if you're kind of want to take a deeper dive, but don't want to dive too deep. And a lot of times research papers just aren't meant for the casual reader. It assumes a lot of knowledge, whereas I think this document really nicely builds on some basics and then dives deeper into the weeds. Also, as some of you may have noticed, there is a new RP 46 that it at least went out for ANC public review, and that time period ended. I think it was earlier this week, actually. So you can no longer request it to review it from the IES, but it does mean that at least it's been out, it's been reviewed, it's gone through the public review process, and gives some hope that maybe it'll actually be published in 2023. And I would say this is just something that's continually been requested. Is the IES going to come out with some guidance to really help in this area? And so hopefully that will be coming soon. And with that, I'll wrap up.
Thank you so much, Andrea. It's been wonderful listening to you for the past hour, and thank you for spending time and educating us on circadian lighting. So with that, if you have any questions, please email the IAS Raleigh section at gmail.com, and we'll share those with Andrea. And I'll turn it back over to Christine.
And Andrea, thank you again so much for your time today. And we're thankful for all of our continuing members and your participation in today's webinar. Keep an eye on your email to sign up for our next education webinar, and we hope you enjoy the rest of your day.